Okay, continuing our work on quadratics and solving quadratic equations. The last screencast was on solving by factorization, and going right back up the top here, we're looking at a section on quadratics. First part of that section, solving quadratic equations, and we looked at the three ways of doing so: factorizing by factorization, and that was indeed our first screencast on factorizations. We're going to move on today to looking at solving quadratics by completing the square, and then hopefully we'll have time also to throw in use of the quadratic formula. So solving by factorization was looked at in the last screencast, and we're ready to look at another method here, and that is solving by completing the square. Now, the first thing to recognize about perfect squares are that I'm sick of these grid lines. I'm going to go in here and get rid of them. Okay, first thing to acknowledge here really is that when you have a perfect square, and you've probably been through this process before, it's not x squared plus 16, it's x squared plus 8x plus 16. Why? Okay, well, it's x plus 4 by x plus 4, and first, outside, inside, last. First is x squared, the outside and the inside give us a plus 4x plus 4x, so it's plus 8x, and the last gives us 4 times 4, 16. So the best way I find to, when you're expanding a perfect square, is to yes, take the x squared, and yes, take the 4 squared, but also take double the product of those two terms, 4x. So that's the 8x. So that's got to be in there. And the thing to acknowledge is that, and you've probably done this before, so I won't labor the point, but the relationship between this number here, the coefficient of x, and the constant term is such that this coefficient of x is halved, divided by 2. Then it's squared to arrive at that number there. So that'll be a feature of all perfect squares, and as if you don't believe me already, x minus 7 squared. All right, what did we just say? Square the x, double the product of the two, square the minus 7, always a plus on the end. Now try it again, halve the minus 14, that's minus 7, and square it. Remember, you're squaring minus 7, that gets you the 49. So that's tick, that's a perfect square. Okay, so working in reverse, if we need to solve by completing the square, or if we just need to complete the square on a quadratic, we need to create a situation where we have this feature that this number on the end, the constant term, is half the square of half the coefficient of x. Okay, so let's get down to an example, pinching one from the textbook. So solve, and this is typically the scenario: solve x squared, what does that say, plus 10x equals 6 by completing the square. Now, if it didn't instruct me to solve this by completing the square, I probably wouldn't. I'd probably use the quadratic formula, I suspect, and we'll get to using that technique after this. Right, so what we do here is go, okay, x squared plus 10x equals 6, terrific. I need a perfect square. So what I'm going to do is create some space for this third term here. Now I know it's going to be a plus, and I know it's going to be half of that, which is 5 squared, is going to go in there. So I need a 25 in there, and because I've added 25 to the left side, I've got to add 25 to the right side. So don't forget that what you do there, you have to do there. So now I've got, on the left hand side, I have x plus 5 all squared. So this half of the coefficient of x will always be that number there. X plus 5 squared equals 31. Now take the square root of both sides, that's plus or minus the square root of 31, and therefore x is equal to minus 5, taking the 5 over, plus or minus the square root of 31. And we've solved by completing the square. Right, let's do another one. X squared minus 12x equals 3. So solve x squared minus 12x. I'm going to say minus 3 equals 0 by completing the square. CTS. Okay, so what I would do firstly is I'd say, right, well, get rid of that 3, it's going on the other side. Because what I need to do is I firstly need to clear a space here for the completion of my square. Okay, so then I go, righto, this minus 12, I halve that, that's minus 6, I square it, that's 36. So I'm adding 36 to both sides. So what have I got on the left hand side now? I've got x minus 6 all squared, and I've got 39 on the right side. So x minus 6 is equal to plus or minus the square root of 39, and therefore x is equal to 6 plus or minus the square root of 39. Okay, let's do an ugly one. X squared minus 3x. So solve x squared minus 3x minus 1 equals 0, again by completing the square. It's typical to be asked to use this method, in which case you have no choice but to go ahead and use it. So what do we do firstly? Clear a space. Secondly, alright, here we go. It's an odd number, so it makes it a bit harder. That there is minus 3 over 2. Sorry, half of that is minus 3 over 2. When it's squared, it's 9 over 4. I know that because I square minus 3, I get 9, I square 2, I get 4. Okay, so let's add 9 over 4 to that side as well, and we're away. Okay, there's another little technique with these ugly ones. I know the left side's easy. I know that it's x minus 3 over 2 all squared. That's not a problem. Over this side, let's get this as 4 over 4 plus 9 over 4. So we get 13 over 4 here. It's going to be easier for us. I'll show you in a minute why that is. Okay, so I've just made lots of dots. X minus 3 over 2 all squared equals that. Right, what are we going to say now? X minus 3 over 2 is equal to plus or minus the square root of 13 over 4. Now, a little third trick here is that square root of 13 over 4 is equal to the square root of 13 over the square root of 4, which equals the square root of 13 over 2. Okay, splitting your fraction up as a surd, splitting it up so that you can write your the square part of that fraction as a whole number is pretty good. So now what have I got here? I've got x equals 3 over 2 plus or minus the square root of 13 over 2. And you can see the benefits now of doing that, because I can put those two fractions together to form a nice single fraction, 3 plus or minus root 13 over 2. That is our solution. Superb. Okay, solving by completing the square. I'm going to quickly look at solve by completing the formula, just because it's not worth a screencast all of its own. Solving by use of the quadratic formula. Okay, the magic formula, you know what it is. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Marvelous. Now that is for that's for ax squared plus bx plus c equals 0. Alright, so that quadratic formula solves that equation there. So example, solve. All right, let's do this one we did up here, this first one. X squared, no, the second one, x squared minus 12x minus 3 equals 0. X squared minus 12x minus 3 equals 0. Okay, the first thing I'd do if I just had that would be to try and solve it by factorization. Multiplies to 3, this is what I'd be thinking, multiplies to minus 3, adds to minus 12. There's nothing there. So when there's no factors, so I can't solve it by factorization, which is the preferred method, then I would go immediately to the quadratic formula. You might like to go and complete the square. That might be your method. I'd go straight to the formula. A equals, I can just see straight away here, A equals 1, B equals minus 12, C equals minus 3. So in we go to the formula and solving that way. X equals minus B. Now that's minus 12 then. Plus or minus the square root of B squared, 144 minus 4 times A, I'll just put these in brackets, times C, it's minus 3, I'll be careful there, that's a 4, that's a minus 3, and this is a minus, oh, okay, we're going to be careful with that. This says 12 plus or minus square root of 144 minus 4 times 1, 4 times minus 3, that's minus 12 over 2. Is this the same question I did a minute ago? It doesn't look minus 12x minus 3. It is. Okay, what's that say? 156 now. 12 plus or minus square root of 156 over 2. Okay, 56, what's that? What goes into 156? 39 times 4. So this is where we can simplify that to root 4 times root 39, and that's why we get 12 plus or minus 2 root 39 over 2. Now I can divide through by 2 to get 6 plus or minus root 39 over 1. And there's a solution. Now actually you can look at that and go, right, I've taken 1, 2, 3, 4, 5, 6 steps over that, whereas if I'd used completing the square, it was pretty quick, wasn't it? I got the 3 across there, I 36 to both sides, I wrote it as a perfect square, x minus 6 all squared equals root 39. I already had it simplified to root 39, I took that across and it was done. So that was 1, 2, 3, 4 steps. 4 steps plays, 6 steps, maybe completing the square is the way to go. Alright, I'm done with this screencast. We've covered all the methods now of solving quadratic equations. It's time to go and do heaps of questions. We can now get right down to in the work requirements up to and including exercise 2F, I reckon. Exercise 2F. Have fun with that. See you later.